Hello everyone, this is Professor Maloney, and today I'm going to be creating a video recording to demonstrate 3 while loops in my COP 1334 classes. These 3 while loops, the first one will be a counter-controlled while loop, the second one will be a sentinel-controlled while loop, and the third one will be a flag-controlled while loop. Okay, so basically, with a counter control, you're just running through while something is true, basically. So we're going to just go through a series of from 1 to 100, and it'll just tell us what number was printed until the program ends. So we'll go basically from 1 down to 100. And then I'm going to put a student challenge for you guys to do something a little extra with what I've already provided you. The second example is going to be a sentinel-controlled loop. And a sentinel loop is not the same as counter. Of course, it's not the same. With a sentinel-controlled loop, basically, we're going to assign a value, and I'm just going to call this particular value, I've just hard-coded it, but normally we would do it with C input statements. But just, again, to get the idea across, because then I'm asking you guys to do another challenge, all right? But so basically the sentinel is going to be 13, and we're going to have the user input numbers. So our little test will just be to input numbers like 10, 11, 12, skip 13, then 14, 15, 16, then maybe put in 28,312, and then put in 13. And obviously it'll go through the loop until we do enter 13, and then that will end the loop. And then again, I'm going to add a challenge for you guys. And then I'm going to do a flag-controlled loop. And the flag-controlled loop is one you'll have fun with, because that one you're going to really get to guess. I'm using the rand number function, okay, to allow us to guess a number that the rand function or the random number function will return. And I'm going to give us like 100. I mean, in terms of, we're going to pick numbers from 0 to 99. And we'll just do it the way I recommend, basically, which is to enter, well, it doesn't matter. It doesn't matter which way I do it. But bottom line is, we're going to just get to guess that number, out of 100 until we get it. And then I'm going to ask you guys to put a little bit of extra code in to restrict the user to perhaps 5 tries. And if you use good common sense, good logic, you can answer, even with 100 numbers, you can get the right guess in about 5, 6, 7 tries, again, out of 100 numbers. So it's pretty easy to do that. But anyway, that's what we're going to do. So I'm excited about it. I hope you're excited about it. And then next week, we're going to start for loops. Well, the next class, I'll demonstrate a couple for loop examples. And again, I'll have a couple student challenges. All righty? All right, let's get to it. So I shall share my screen, my whole screen, and allow that. Okay. All right. So here is the video I'm doing. So here's where my little content is. I'm just trying to get myself oriented again. All right. So I've already put all what I want you guys to get in here, because it would take me way too long to code them all, but I will demonstrate all of this. I will demonstrate everything I've got in here, okay? Nice and easy with my challenges. All right, so we're going to start with the easiest one. The easiest one is, well, let me just again say here. So chapter 5 has while logic. It also has for loop logic, and it also has do while loop logic. So today I'm demonstrating 3 while loop examples. I said the first one would be a counter-controlled while loop. Specifically, we're just going to have the program basically run through or iterate through 100 numbers and then put a little message after each iteration. Okay, that's all that one's going to do. The second one is a sentinel-controlled while loop. And I mentioned I'm going to hard code this to give a sentinel value of 13. So we'll all know the answer, but we'll then still code it where we'll test it. Like we'll enter numbers like 10, 11, 12, skip 13, maybe then 14, 15, 16, and then come back and put 13. You know, again, just to show you the difference. And of course, then again, I'm going to have a student challenge. And then the third one will be a kind of a fun one. Hopefully you'll enjoy it. It's a flag controlled loop which uses a Boolean value, basically, which means we're going to be guessing while we haven't guessed the right number. And then I'm going to ask you guys to do a challenge to restrict it to maybe 5 tries and just go from there. Alrighty? Okay, so first one, I'm going to go ahead now. So basically I've commented everything out. And remember from way back in chapter 2 or so, there's single comment lines which are // 2 forward slashes. That's just a single comment line. So this one, just because I typed a lot and I typed it all here, word wrap brought it down to the next line. Word wrap brought it down. So technically that is only one line. But here where I do a /*, that starts a multi-line comment, okay, which comment, which at this point I commented out the whole program because I didn't want it to interfere when I was doing the others. So then a /* starts a multi-line comment and it ends with an asterisk slash, as you learned in chapter 2 or chapter 3, well, probably chapter 1 actually. So anyway, so now we're going to go down and do it. All right. So let's review the code first, and then I shall run it. And again, I'm going to talk about some things and how we can change it up and whatever else. All right. So we need our pound include IO stream, as always. We don't necessarily need the namespace standard, but I like you to use it. Remember, if you don't have namespace standard, you need to type std : before using every coot statement, okay? Before using anything like an end L, okay? And if I was doing C input, same thing. So the namespace standard is good. It makes your coding a little bit easier. And it also looks a little bit better. Now, some programmers, especially the older programmers, they don't necessarily like to make change, and they are happy to just say that maybe they don't want to share as much of their code. So with standard : it might seem a little bit more difficult. But anyway, all right. So we're in our int main. Always declare our variables first, and I'm just going ahead and also do the initialize. So this is steps 1 and 2 with what I always tell you guys. So we're assigning the counter to 1, and then it's just run the while loop as long as the counter is less than equal to 100, and that will run 100 times. Okay, so let's check it out, and then we'll come back and talk about it. So 100 times, that should have just iterated through 100 times. I'm going up to the top, up to the top, up to the top. All right, so here we go. Enter an integer greater than or equal to 0 and less than 100. Okay. Oops, wait a minute. Where am I? That's another one. Oh, sorry about that. Okay. Yeah, I was just going through the third one. Okay. So, but you guys, what I just did here is this one. So I'm going to go up to 1. So there's 2, there's 1. So here's where this one starts. Current counter value equals 1. Obviously, I'm just picking up my coot statement, right? Current counter value equals, and then I'm putting a space after the equal sign, and then I'm picking up the current counter value. So here it starts at 1. I mean, it's 1 because I started the counter at 1, right? And I'm running it while it's less than equal to 100. Can't get that thing out of the way. So while it's less than equal to 100. So first iteration, it's a 1. And it says, so loop condition. So then after the counter, then I'm just putting another coot statement here by just adding my double quote and a space. So loop condition is still true. Okay. And then I'm letting you know or reminding you that I'm incrementing the counter variable. That's what's here, incrementing the counter variable, ... So it's incremented here at counter plus plus. When it comes to counter plus plus, it goes to the top of the loop where the while statement is. Okay, so while counter less than equal 100, what is count? It's now 2. All right, so it's going to put the same thing. Current counter value equals 2, so the loop condition is still true. All right. And then it's going to go to 3, 4, 5, 6, 7, 8, 9, 10. You see here, we're up to now 13, 14, 15. Now we're up to 20. We're up to 24, 5, 6, 7, 8, 9. Now we're up to 36, 37, 38. Now we're up to 40s. Let's scroll down a little bit now. Now we're in the 60s, 64, 65. Now the 70s, 75, 76, 77. Now the 90s, 94, 95, 96, 97, 98, 99, and here we go. So incrementing the counter variable after it was 99. So counter here was 99. Is 99 less than or equal to 100? Yes, it is. So that's this one. So the loop condition is still true. Then, and of course it told us 99. It got the 99 from this counter variable here. Okay. And then I put the little, so the loop condition is still true. And then I put the incrementing the counter variable. And so on the incrementation, now down here in line 15, it's 99 plus 1. So now it's 100. Well, comes back up to the top. While the counter is less than equal to 100. Is 100 less than 100? No. But is it equal to 100? Yes. So less than equal 100 is true when counter is 100. So here it's still true. Okay. And then the last statement is incrementing the counter variable. It doesn't go further because when it does at 101, the value is not true. So you don't see, there's no more COOT statement telling us what the counter value is. All right. So that is that. Now this is a nice easy one. I know. But so your challenge is to use an if expression, so if logic, in other words, to see if the while loop condition is false. And when it is false, use a COOT statement to say the loop has ended because the loop condition is now false. So all you have to do is figure out where you're going to put an if statement. Okay. And that if statement is only going to read, only going to be output when the statement is false. In other words, when it gets to 101 in this counter, then when it comes to the top, it's going to be false because it's not less than equal to 100. It's going to be 101. So when it's 101, then what? You need to put in logic so that you can tell us that, oops, the counter value is now 101 or whatever, and that is not false. Or just tell us whatever I put here. The loop has ended because the loop condition is now false. I should have made you also put the counter, what the new variable value is. But anyway, that's the bottom line, all right? Okay, so now let's just do a couple of these things to also illustrate how easy it is to, to get an infinite loop. I mentioned this in class the other day. So while the counter here is 1, I can put while counter equal 1. Let's get that as 100. Now change it to 1. There's a problem here. Why? Well, remember what the difference between an equal sign, which is an assignment statement, and an assignment statement takes a value that's on the right side of an equal sign and assigns it to a variable on the left side of the equal sign. So in other words, you can't do an equal sign when you're dealing with a while expression. Instead, we'd have to have a variable, and the variable would have to handle a number like an integer, okay? And we would then assign it to that variable. So when we're doing it here, we're using what we call the relational operators. Remember the relational operators? We said there are 6 of those. There's equal, equal, there's not equal, there's less than equal, there's greater than equal. So what I want to do now is add a second equal up there. Okay, so now we're saying while the counter equals 1, do this. Okay, and what's going to happen? It's only going to run how many times? 1 time. Why? Look at it. Counter is 1. Okay, counter is 1. Here is showing that it's 1. That's the initial assigned value, 1. And 1 is equal to 1. So therefore this is true. So while it's true, it puts current counter value equals 1. So the loop condition is still true. And then I put that incrementing the counter variable, and I'm incrementing the counter. If I increment the counter, what's going on? Well, it was 1. So while it was 1, it's in here. So the first time it reads the 1, yeah, it's true, it's in here. And down here, though, we increment it. Counter plus plus is the same as saying counter equals counter plus 1. Okay? So it's now 2. And once it increments the counter, it comes back up to the while statement. So now it's 2. So while counter equal 1 is not true because the counter is 2. So it's false. So it leaves up here, and this is where I want you to put a statement. The loop has ended because the loop condition is now false. But I mean, that was just demonstrating, okay? So demonstrating with that equal, but you're going to do it with less than equal. So less than equal and 100, right? So there again, it will then run through the entire sequence of 100 numbers right up to there, all right? Now, remember I also mentioned in the overview recording for chapter 5 that we have, there's a lot of ways to do something that's very bad, but programmatically it's easy. It's just simple mistakes. You know, they're called logic errors. We can get an infinite loop. That means it's going to run forever. How could I do that? Well, again, let's say here, rather than equal, because typically we wouldn't do that. But if we have less than equal to 100, okay, and let's say we make this number 100. Actually, I'll make it 1 so that you'll see the difference. Okay, so I'll make it a 1. Oops, sorry. So the counter is 1. While it's less than 100, okay, it's going to keep going, right? And you saw right over here, it's up to 100, 99, 98, 80s, 70s, 60s, 50s. So here it went through the 100 values. But what if I don't have a counter? What's going to happen now? Well, look at the code. Okay, so we're starting with int counter equals 1. We've got a good statement, a good while expression. While counter's less than equal to 100. Yeah, that should mean that it goes 100 times. Because if you start at 1, you go all the way up to 100. You know, you've got all those numbers. 100 numbers. So it'll loop through, loop through, loop through, loop through. Or will it? Let's run it. Let's run it. Oh my gosh, look, the value is 111111111. It's never changing. Okay, so you got to escape. Oh, can't even escape. Oh shoot, I didn't really intend to do it that way. I'd say, well, what am I going to do now? So let's go ahead and hit my stop right here. Okay, so bottom line is I had to manually terminate it. It would have went forever. All right, why would it have gone forever? Well, the counter is 1. And it didn't go to 2, remember? See, it's 1, 1, 1. And if I go back, I'm scrolling up now with the little mouse wheel. So 1, 1, 1. It's still 1, 1, 1. If I would have had a counter value or a count of how many times it went through the iteration, I'd probably be in the hundreds right now. Okay. But anyway, it doesn't change from 1 because here in line it starts at 1. 1 in line 11 is true because 1 is in fact less than or equal to 100. So we iterate here with the current counter value equals. So the loop is still true. We put the counter number and it's telling us it's always number 1. And then we're incrementing the counter variable. And we're never incrementing the counter variable though. So even though we said we are, we're not. Why? Because I commented it out. So you understand what happens. So very, very easy to make. That would be a logic error, but that logic error could kill a program because it's, especially if you got a high-speed computer and you got tons and tons and tons, like millions and millions of records. So you can, you know, easily have it run forever. Okay. All right. So your challenge: use an if expression to see if the while loop condition is false. In other words, just to check. And if it comes to false, then put a statement, a COOT statement. The loop has ended because the loop condition is now false. All right, so that's that one. So now I'm going to comment that out. Oh, you know what? First, I'm going to let you guys take a picture. So let me make it wider for now. So take a picture, please. So it ends on line 19. Let's see if I can get it all in. I cannot because of my big comments. There are too many comments. Let's see. No, I'll just have you do it with 2 pages. That's all. Okay. So let's see if we can just move this here. All right. So that, no, we can only go down to about number 10 at this point. You know what? What I'll just do is get rid of that one. Let's see what I've got down here. All right, so we can see that that is just a opening curly. Let's see, I can't move it down any. Let's see if I can just touch it, just touch it. Can't touch it quite. Well, I mean, that's, you know, you missed the little tiny thing on top. I guess it's better to miss that than the other. So just go ahead and take a picture of that, okay? Can't quite get it, and that's just too darn low. Well, you know what? I'll just get rid of this variable word here, and then it'll come up easier. Always initialize counter. So that's the same as variable, obviously. So now let me just go down a notch to get it to, or up a notch. No, I can't go. What am I saying? Down. No, I cannot. You know what? Because I made my screen so big. Let me make it a little bit smaller. Let's see now what we have. So 1 to 15. Well, you know that the loop there on the bottom is 15. So just go ahead and take a picture of that. All right, so 1 through 15. All right, so 5 more seconds. And you know they're on line 15, that's a closing curly brace. So that's line 15, 5 more seconds. Okay, all right, so now let's go down to 16. Oh, yeah, 16, that's obviously over. Okay, so shoot, it's too late now because I don't want to keep going. So I'll just say, so then anyway, do that. Well, you want the student challenge though, so you need this part. So I said it was 16, right, that we were on. So that's where we are, right there. So just take a picture of that. Let me go down one more. So the student challenge, use an if expression to see if the while loop condition is false. And when it is false, use a COOT statement to say the loop is ended because the loop condition is now false. So take a picture of that. 10 seconds. Okay, 10 seconds. All right, so that's done. Now I'm going to delete, so now I'm going to end this one with putting an asterisk / there, meaning again the multi-line comment end, and up here I'll just do a /*, which is the beginning. So now the first one from 1 through 20 whatever is commented out. So now I'm down to the second one. Okay, so this is the one I want to talk about now. So delete. Okay, I'll get rid of the comment there now, the /*. So now I got to get rid of the asterisk / here. Okay, all right, so now this one's a sentinel loop. Let's see, let's go down here. You know what, let's have you take pictures first, and then that way I'll do the running after. So here's the start. So from line 22 to line 38, please take a picture of that. So, and while you're doing that, I'll just say the next while loop is a sentinel-controlled while loop. It uses a variable and checks to see if the variable is equal to the sentinel, in comparison to the first example where we used a counter variable to just run the program while the counter condition was true. All right, so here we're assigning a constant. Remember, if you assign constants, you normally make the constant uppercase, all uppercase. That's the recommendation. Okay, so I used sentinel in caps, and CONST stands for constant. Okay, all right. Of course, I could have gotten rid of a couple of these spaces. But anyway, so that's down through line 38. So sorry about that, not doing that. So let's go to line 39. All right, so line 39. And that, let's see, the next one is the one after that. So let's go ahead and enter a few more. So 39 again. All right, so take a picture of that, and now a challenge on this one as well. So here, line 39, down to wherever I am there, and I'll read the challenge while you're taking your picture. So the challenge activity, add programming logic to tell the user what number they entered as part of the COOT statement and add a little more code to see if the if statement logic to tell the user what the sentinel was. More code to, oh yeah, more code to the if statement logic to tell the user what value the sentinel was. Okay? So in other words, here you want to put the sentinel value, and above that you want to put the numbers. Right? So when we run it, here's what's going to happen. Remember, let's read my comment again. So sentinel-controlled while loop uses a variable and checks to see if the variable is equal to the sentinel in comparison to the first example where we used a counter. So, but we're telling us this, right? So we know the answer, so it makes it easy to test. All right, so let's just run it. So I get to enter as many numbers as I want. I can start at 1, go to 2, go to 3, go to 4, go to 5, go to 6, go to 66, 589, come back down to 4789. Any number I want to enter, 12, 14, oh, that was not 14, 14, 15, 11, 12 again. Now what have I not done? 13. So here's 13. The while loop has ended because you entered 13, which was equal to the sentinel value. All right, so that's a sentinel. All right, sentinel. All right, so let's look at the code. So pound include again, IOStream, yes. Using the namespace standard, yes. When you use a constant, I mentioned to you when we were in either chapter 3 or 4, I think it was actually in chapter 3. Yes, it was chapter 3. I mentioned that you declare constants above int main. You do that because when you see a constant, okay, you may see the value. See here, the variable name. So sentinel, okay. And even though I've only used it twice, a big program could have used it dozens of times, hundreds of times. So if I have to fix this at some point, and normally you do that for like a discount rate or perhaps a tax rate or perhaps a something else, then if you change it just in the one spot, like you change it up here, then that automatically changes it everywhere else because these things are just referring to the variable, right? And here's where the variable has the value. So always when you do constants, you assign them with the const and then whatever the data type is, int or double for the most part. It'll also be a string, obviously. And sentinel, in this case, equals 13. All right, okay. So we told the user, enter a number. And of course, with C input, we have to have the variable. So we're putting the variable num entered, okay? So here was my step 1 declare variables here. So num entered, and it's num entered. And then we're saying while num entered is not equal to sentinel. Remember, if it was this is a relational operator. So not equal is like using equal equal, but equal would mean if num entered is equal to the sentinel. And you have to use the term equal because for the relational operator, you have to use equal twice. Otherwise, you're assigning equal, and you can't, meaning with one equal sign, you'd be assigning it. You can't do that to a while. You'd only be able to do that to another variable. And of course, we don't want that, right? We're just running through a loop. So you saw that I entered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, about 11 numbers. 1 through 6, then I entered that, 7, 8, then that, 9, then that, 10, 11, 12, 13, either 13 or 14, but regardless, I entered quite a few, right? So while the num entered, meaning what the user entered, see, num entered is from the user. So 14, 143, 15, 11, 12, 13, all these are from the user. 6, 66, 589, 47, 89, 12, 5, 4, 3, 2, and 1, all from the user, okay? So the user is num entered, and then when he or she enters that number, we're comparing it. Well, is what they entered equal? That's the comparison. Okay, so it's relational here. We're comparing it to this sentinel value, which is declared up here. And of course, none of the numbers except 13 are. So this is always going to be false until, and if really, because again, we wouldn't normally have Sentinel this way. Normally you'd use it like a random number, but I'm using the random number in the flag while example, which I'm doing next. Okay, so let me count. I think it's 8 and 24 is 32 minutes. If I did that right, so 24:32. So I want to make sure that I'm no more than an hour or so on this. So I'm probably not going to stay too much longer on this one. The Sentinel is not a real big deal, but what could I do to change it up to show you things? So if you want it, well, let's look at your challenge again though. So add programming logic to tell the user what number they entered. So right now, see, it says value entered was not equal to the Sentinel value. Now, you can say, yeah, but professor, we're seeing number. Yeah, we're seeing it, but you to tell the user to know how you're taking your variables and how you're putting them in, right? So you can do that. And then I said to also put in, when you're testing it, when this is true here, that you're also putting the value, even though, well, obviously if you enter the number 13 is the one, so it's equal, but you would then also put the variable value to make it true all the way. All right. Okay. So, and I already asked you to do pictures of this one, so I shall let that go. All right. Now let's comment this one out. So we start with that asterisk slash at the end. That means we need a slash asterisk at the beginning. That one ended that one, so right here, slash asterisk. Okay, so now the first two are done. All right, now the next one is this one. This is a flag Boolean variable, flag Boolean while example. Okay, so I'm going to go ahead and again have you do the picture first, and I don't really want you seeing the slash asterisk and getting confused with it. And you don't need that first part where it just said while loop example 3. You just want it to say, let's just see if I can do it with this thing. That. Okay, so just take, oh, that gets us again. It's unfortunate that to my, let's see, I want 71 only, I guess. Okay, that's where I want. I'm not going to, don't worry about the fact that you don't see while loop example 3. Well, you know, I should be able to go down just to here more. I should be able to. I mean, up down a little bit more. Okay, there we go. Okay, so take a picture from line 57 to 71. And while you're taking the picture, I shall say, so now remember here, this is the beginning of the program. It's not on line 1 because I've got 2 other examples above here. I should have said that for the previous one too. So when you're looking at your pictures from your phone, in this case, line 57 is the first line, even though it's a comment on while loop example 3. All right, so let's click over here so that, shoot, now I messed up again. So make sure you get that picture there. That's more or less it. Okay. All right. And remember, that's a semicolon next to that cursor there. All right. So 5 more seconds to take a picture from 57 to line 71. Dun, 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 dun. All right. You're done. Okay. So now let me go down to 72. Okay. So 72 here, I don't get everything. So you're going to have a third one. So go from 72 to the first line of the student challenge, but you're not going to see the student challenge there. So line 72 to line 91 is page 2, we'll say, for this program. Remember, this is the more fun one. This one, we're really doing a guessing game. And I'm going to show you how you can guess to maximize your efforts, and some of you probably already know that. But anyway, so 5 more seconds here. Take a picture, line 72 to line 91. Okay, so let's go down now and move it right here. So I need line 92. Oh, it's actually still line 91. You know what, I'll just leave it like there. So line 91 to line 94. You don't need this, so let me get rid of that. Okay. All right, so student challenge 1, while you're taking this one, add variable number guesses and use COOT statements to show the updated number of guesses that the user is on with each new guess including which guess number they took when they picked the random number. And that's assuming if they got the random number right. And then shooting challenge 2, add another variable, int max guesses, and modify the while statement to use the and clause, the ampersand, to restrict which makes it a compound or complex condition, in that while expression. To restrict the number of tries, perhaps use 5. And if they don't guess the number within 5 tries, add a coop message saying you have used up your 5 tries. All right. So this is a cool one here, like I said. Right. So I'm going to go up here now, take away the comment that started this one right here. All right. Now let's run it, and I'll show you what happens. So let's go down here to the bottom. So enter an integer greater than or equal to 0 and less than 100. What I would suggest you always do in these is cut everything in half, because that way you're eliminating half the numbers. Of course, you may get the number right, but you always have the same 1% chance because it's 100 numbers. So you got a 1% chance of getting the number right. But if you don't get it right, and let's say you say half, so 50, the answer is going to tell you that you're either less than or greater than the number. Watch, I'm going to put in 50, okay? It says your guess is too low. See, so I eliminated from 0 to 50. So what do I got left? Well, 51 to 99. That's only one guess. I want you to give your users 5 guesses. So watch what happens now. So obviously I picked 50. So just with that, now there's 50 left, right? So the ones that are lower than 50, well, 50 and lower are over. So I want more or less halfway between 51 and 99. So I'll just say 75. Now our guess is too high, but I've only had 2 guesses. But I want you to tell me that as part of your challenge. So 75 is too high, 50 is too low, so I'll cut it in half. So I'll say again about 14 of that or so, 13 of that actually. So I'll say 63. So 63, oh, it's too low. So I know I've had 3 tries, even though you're not coding it yet to say that. So 63 is too low. 75 was too high. So now I've got between 64 and 74. So I'll say 69. This is number 4. Oh, it's too low. So the answer is either 70, 71, 72, 73, or 74. So there's still quite a few, and this is going to be my 5th try. I was wanting to get it in 5, but I think I said at the beginning of the video, 5, 6, 7 tries, you can get pretty well any number. But let's see. So let's see, 70 to 74. I'll say 72. Okay. Too high, darn it. So now it's either 70 or 71. My 6th try, I'll say 70. Yes, I got it. Okay, so that's how this thing works. Beautiful, beautiful, beautiful. All right, so let's talk about the code. This is a lot of code in this case. All right, so right here, IO stream. All right, so now we're going to use IO stream like we always do. It's just basic input output. But we're adding a pound include for C std lib, or what we call the C standard library. This allows us to use the rand function, which is the random number function, because we're not hard coding. The good thing is we're not hard coding the number, and like we didn't know the number until we guessed it, but I guessed it at what was it, 70. 70 was the right number. Out of 100 tries, out of 100 numbers, it took me 6 out of 100 to get it right, because I did half, then half, then half, then half, approximately, and then basically got it. All right, so that's that. So anyway, C standard library, and that's a pound include, so you do the less than and the greater than, and you spelled exactly like this, C std lib. All right, now, because I want us to be able to run this 1,000 times, if you don't include a C time, okay, then when you run this program again, it would most likely have the same number, 70, as the random. So the pound include here for C time allows the random function to change with each attempt. All right, So CSTD, LIB, and C time with the less than and greater than on them. Okay. All right. Now, after that, declare our variables. So we're having one for num. This is the one we're going to store the random number. Okay. And then guess, which we're going to use to store the number that we're guessing. And then we need a bool. Remember, Boolean is bool, and Boolean values are true or false. The is guessed is going to allow us to tell the user, whether they've guessed the right number or not. Oh, you know what? Didn't I say you were going to do this? I forget now. No, because this is for my original logic. All right. Okay. So then I need the srand time because I'm using this C time. All right. So this is needed to ensure that you get new random number each time you run the program. Okay. The next one is perhaps the most important line, and I talked about this in either chapter, I think it was probably chapter 4, but I put a few examples here because I want to make sure we understand again. Remember, this is modulus, okay, which means remainder, all right? So we're doing the random function, and that's why we need that C standard library, CSTD-LIB, as part of our pound include. And what this thing here is doing, it's allowing us to pick numbers, okay? I'm using 0 to 99 as an example because I'm not going to really restrict the user. If they type in 2,212, I'm letting them. Of course, you can fix that if you want to really only allow it to be from 0 to 100. But here's what's happening, all right? And I'm doing it with examples. So I'm saying the number 1, okay? So if rand returns the number 1. Here's what it does to determine that it's number 1. So regular division, you'd obviously divide 1 by the 100 and you'd get 0.001. That would be the actual division. But when you're doing remainder, which is modulus division, which means this percent sign, let's get over here, the percent sign, okay? What we want to do with the percent sign is we're taking the remainder. So if you have a 0 and you divide 0 by anything, the answer is 0. So in that case, it's going to be a 0, right? So 0 is 0. If you divide 1 by 100, you can't do it. Remember, it only works with whole numbers. So 1 into any of these won't work. 2 into any of them. None of them will work because the number 100 is the highest you can possibly have to get the whole number. But just think of the number 1. So 1% 100, meaning the number 1 was returned. So it doesn't go into 100 divided into 1 time. It only goes in the value of 0.001. So it's not the answer. So that's 0. And what's the remainder? The remainder is the number. And the number was what? 1. Okay, so that's how we get the 1. If it's a 2, okay, a 2 also can't go into it because it's not 2 into it 50 times. It's 100 divided into 2, which means 0.002. So the answer is 0, but percentage is giving us the modulus. So it's going to only give the return, and the return then is number 2. All right. So let's fast forward now. So we did 0, did 1. Let's go up now to the number 99. So 99 right here, okay, percent 100 is 99 because again, it can't go into it. Like 100 would go into it 1 time, okay, with a remainder of 0 though. So 100 and 0 both give 0, just to let you know. But 99 can't go into it, so it's 0, but what's the remainder? 99. So the cool thing about using 100 is it's nice and easy. The remainder is always going to be whatever the number is, from 0 up to 99. Okay, so random number gives us a 99 is what we're going to make an assumption on here. So 99% 100 means don't divide it, but I want to know the remainder off if you divide it. So 99 can't go into 100. 100 can't go into 99 a whole number of times, so it's 0. But the remainder would be 99, okay? Then if it is a 100, just saying, so then if it is 100, 100 does go into 100 1 time. So if it goes into it 1 time, what's the remainder? 0. which is the same as if it's 0. And that's why I said we're doing it from 0 to 99. All right, but that's the way it works. Beautiful. And make sure you review this 3 or 4 times till you understand it. All right, very important. So num is the variable, right? Well, one of our 2 variables. And I said this is to store, line 65. Int num is to store the random number, which comes from line 69. Okay? All right, so random number is there. Now, is guessed. Is guessed means we either guessed it right or wrong. Remember, it's a Boolean up here in line 67. So line 67 tells us it's a Boolean. So we normally start something like that as false. And it's, again, called a flag. It's going to stay false until until if, depending, and if you change it based on what I'm asking you to do in the challenge, then you're going to restrict the user to only get 5 tries. It took me 6 tries to guess that number. Okay, and I want to do it again, though, by the way, before I stop our program. We only have 12 more minutes to make an hour, so I don't want to talk too much, but I want to continue going a little bit. So is guessed equals false, and it's going to be that for the most part every time, right? Because you're guessing out of 100 numbers. Well, even though I said if you do it the way I did, you can probably get it right in about 5, 6, or 7 numbers. Anyway, and then the next one is a while. Remember, it's a while loop. So we're saying while not is guessed. Okay, so that means what would while is guessed? Is guessed is true. So not, remember the silly exclamation, are the opposite. So this is false. So while loop runs while it's not guessed, meaning it's not is guessed. Okay, so then we tell the user, so the while statement, remember, is always the opening curly, okay, and then the closing curly for that. Really, if I click it there, you see it's a little bit grayish in line 87 and a little bit grayish in line 73. That's the opening curly. This is the ending curly. If I do the same thing on this one down here, that's for the beginning of the program, which is right here, the one after int main. Okay. But so while goes from 73 down to 87, right? Okay, so while it's not guessed, then what? Well, we're saying enter an integer. So let's go to the first one here. Enter a number. So, oh, sorry, value, wait, that's not that one. Where am I? Enter an integer greater than or equal to 0. Yeah, all these are saying that. Well, starting here. So enter an integer greater than or equal to 0. And less than 100. And I said I just start with 50. So I did 50. Okay. Then it said you guessed the, well, sorry. Then there's the if statement, which we have to determine if it's correct number or not, right? But if it's not, we're going to an else if and then an else. Why? Well, think about it again. We're entering a number. The number can be right. We can guess the number. So in the first try, 50 might have been right. It's possible. It was a 1% chance, but it could have been right, in which case we guess the other variable up here, guess, right here, variable to store the number guessed by the user, meaning in this case me, let's say, or you, okay? So guess at 50 could have been true. And if it was true, then it'd come in here. You guessed the correct number. Okay, and then you flip is guessed equals true, because then the while is not right anymore. It's false, because if is guessed is true, then it's not is guessed, because is guessed is true. Okay, so this is false initially. In line 71, that's false. Is guessed is false. So it's running while it's false. When someone, if someone guesses the correct number, we flip it. So this if, this, again, let's just do it this way. So when I click next to the opening curly, and then a couple lines, so that's line 78, line 82 has that similar grayish color, and that's the closing curly for the if. So you guessed the correct number. But if you didn't guess the correct number, which in the case of 50, I did not. It said your guess is too low. Why? Well, because it then says else if. Else if guess, again, guess is what we're guessing. So I guessed 50. If it was less than num, what was num? Num was the random number, right? So up, where is my rand? Number. So num equals rand. And the random number, we now know it by looking at the end, was 70. Okay? So my if was not true, so it skipped it. Else if, in this case, it says else if guess is less than number, or less than num, your guess is too low. And mine was too low at 50. Okay, so this is where it came. Guess was less than num, so it came here. And then because this is true, it doesn't go to else. It went back to the top. Okay, but if it was not false, like in the case of where I say here it's too high right here, your guess is too high. So in this case, I entered 75. So that was from this one. So I entered 75 and that was too high. Okay, so else is what happened here. So 75 was not the number, so it was false. So it skips it. Else if guess was less than num, it wasn't. It was higher than num, so that wasn't true. So it skipped it. And then it comes to else, and then because it's the only one left, else is then true. So your guess is too high, and then it tells us guess again, right? End the while. So that was the logic. Your student challenge. Add a variable, number guesses, and use COOT statements to show the updated number of guesses that the user is on with each new guess, including which guess number they took when they picked the random number. So here, like it says at the end, you guessed the correct number after we entered the number 70. You can say you guessed the correct number and then put that number 70. So you got to use the variable for it to put it there and say, and you guessed it on the, in this case, I think I said it was the 6th try. Okay. So, but you would do that by having a variable to count the number of tries. All right, so that's one. And then student challenge 2, add another variable, int max guesses, and modify the while statement to use an ampersand. That's a compound condition. So now you would have while it's not guessed, but then you'd want the ampersands in here, 2 ampersands to make an and clause. And to restrict the number of tries, I'd say, do it with 5. If you do it with less than 5, it's pretty darn tough with 100 numbers. If you find that 5 is not enough, you can go up to 10. You can make it anything you want, right? But really with 5, if you do it the way I did, you're going to be pretty close to getting it in about 5 tries. All right? Okay, have a great day, and I shall see you in class. So let's go ahead in here and stop my recording.